For this next one, we're actually going to go way back before we did any of this extra stuff. And I'm going to go ahead and grab 06.extra4. And you could work in this one on this page if you want to, but I'm going to grab all of this stuff, copy it, and just paste it in right here instead. So we've just undone a lot of the extra work that we did. And we're going to take a look at what could we do if this is actually the UI that we're going to build. Remember, we were just pretending that this UI was an example of lots of different components on the page, all consuming the same context. But what if you actually needed to build a grid like this and you wanted to make it super fast and performant and whatever, and these updates happen immediately and everything? So there's a great solution for this specific type of problem called Recoil. And to get started, we're going to need to import a bunch of these components. And I'm going to take that Recoil root component and we're going to wrap everything with that Recoil root right here. So everything's going to go around here, and then Recoil is going to be able to associate any of the Recoil atoms that we create with this Recoil root. So the next thing that I want to do is create that Recoil atom. We're going to use the atoms family. No, just kidding. It's the atom family utility from Recoil. And this is going to give me back my cell atoms. So it's a family of cells. We're going to call this our cells. And then our default value for these cells is going to be a function that returns the default value. And here we're going to take the row and a column, and we're going to return our initial grid at that row and at that column. And so when a new cell is rendered to the page and Recoil needs to determine what that value should be, it can grab that value from our initial grid value that we created here. So now that we're going to be storing everything in this cell, we no longer need to store it in our reducer. So I'm going to come down here and get rid of both of those cases for updating our cells. And we're going to be updating things a little bit differently with Recoil. This also means we can remove it from our initial state in our reducer. And you'll be interested to note that we don't need to bother memoizing this value anymore. Now, because we're no longer storing the grid in our app state, instead, we want to update the grid values in our atoms. And because that's a little bit on the contrived side and implementation detail side, I'm just going to give you that code right here. And basically what this does is it gives us a hook that uses the useRecoil callback, which will accept a set function, and then whatever we pass to the function that we pass. So we're going to call update grid with the rows and columns, and then it's going to go ahead and set the value in our cell atoms. This is a little bit on the contrived, so I'm not too concerned with you understanding the details of this. I mostly want you to observe the changes in our browser and in the performance tab when we implement this. So now that we've got use update grid, let's come down here and we'll grab update grid with use update grid. And then our update grid data is going to say update grid with our rows and columns. Great, and then we no longer need to memoize this at all. We also no longer need to memoize our cell either, because we're no longer using React's built-in mechanisms for updating this cell state. We're using Recoil, which also means we're no longer going to be pulling in the app state anymore to get our cell value. Instead, we're going to use Recoil state. We're going to use our cell atoms that we created above, and we're going to pass the row and the column. And this is going to give us our cell and a function for updating this. We'll call that set cell. And then on our click, we're going to call set cell. And for this, we're just going to update it randomly. In your real world scenario, you'd set it to whatever you need that value to be set to. Okay, awesome. With these changes now, I can go ahead and click on one of these, and that click happened really fast, like way faster than before. So let's go ahead and take a look at the before and after. This is before we made these changes. This is all the way back to before we made any of the optimizations we've made. And this is after we added Recoil. So we're just going to measure what it's like when I click on one of these, and then we stop. And then we'll measure what happens when I click on one of these right here. Wow, that looked a lot faster. And again, there's that weird thing that sometimes happens with the profiler, but that's not when I clicked. Here we have it right there. You can barely even see it. What in the world? Holy moly, is that there's the click right there, 0.94 milliseconds? You compare that to 414 milliseconds. My goodness. I think that, yeah, this is good. This is what I want. So I'm really excited about that. But even though Recoil solved our specific problem for this specific UI, I really want to urge you to think about the abstractions that you're using and not just apply this all over the place. So there is a definite weight of abstraction and complexity that this adds to your code base. And so it's important that the benefit that you're reaping from this complexity outweighs the cost of having the complexity. So I wouldn't put everything inside of Recoil for your code base. There's maintenance issues along with performance issues that you need to consider. However, this looks like a pretty solid solution for this type of a UI, and this is exactly the type of problem that Recoil was built to solve. So in review, what we did here was we brought in Recoil, we created our cell atoms here, we have a mechanism for updating all of the atoms, we created a mechanism for us to update all of those cell atoms when the user clicks on Update Grid Data, and then we updated our app provider and its reducer to not have that state anymore because it's being handled by Recoil. And we updated our grid to reference that update grid hook. And then in our cell, we're using Recoil state, grabbing the atom of the state that we care about, which gives us a cell and a mechanism for updating that cell. And we have a much faster experience for when the user clicks on one of these cells.